Started. All right, so here's the worksheet for today, which is basically just a list of things to do. And you should find a copy of this in your project. Okay. Before I start, any questions? Any general questions? Okay. Anything you want to be reminded of? So your homework assignment is due at 6 o'clock tonight. All you have to do is just do it. You don't have to do anything else except do it. You don't have to submit it in any particular way. Okay. There's that. So here's the topics that we'll talk about today. First, I'll show you how the backups work in SageMathCloud. Behind the scenes, each SageMathCloud project is a Linux account. It's a normal standard account on a Ubuntu Linux server, and the files in that account get copied to another machine roughly every 5 to 10 minutes, at least if you're actively doing something. So they get copied to a second machine. That second machine is snapshotted. It uses the ZFS file system, which has support for full file system snapshotting. So every 5 minutes, that file system is just snapshotted. There's actually a whole bunch of these machines. And you can browse the snapshots that are available on that other computer. And I'll show you how to do that. And the snapshots, they get made every 5 minutes, but after a while, some of the old ones get deleted. And after a couple of months, you'll just have one per month in there. In case you're curious, in addition to these snapshots that are on another computer, every roughly 6 hours or so, when you actively use your project, it will make a backup using Git, using that revision control system, of all the files in your project. And then those get copied to something called Google Cloud Storage, which is a long-term kind of globally distributed file system that Google has. And that's an additional collection of backups. You don't directly see those, but they're there just in case of catastrophe. And then in addition, in case of catastrophe, the files that get stored there get downloaded to some encrypted USB drives that are not physically connected to the internet. So I take some steps to make sure that the data that's in SageMathCloud doesn't get completely and trivially deleted by typing something stupid. So I'll show you a little bit of backups, and then I'll talk about deleting stuff. So deleting files, hiding a whole project, and deleting a project. And then we'll talk about Jupyter notebooks. These are kind of like Sage worksheets, but they're used a lot more in the sciences, and they work a bit differently, and you can use them also here. I'll also talk a little bit more about task lists, because we only touched on that for a second. Something I didn't write here, but I wanted to mention, is that you can edit HTML and Markdown files as standalone files. So if we have time, I'll show you how to do that. You get a live preview on one side of the screen, and then you edit on the other. And there's all kinds of menus and stuff, so you can sort of quickly insert things, even if you don't know HTML or Markdown. And then the last thing we'll talk about is how to write and run programs in various programming languages. Since we're going to start focusing on Python next week, this will be useful. And what we'll do is just create a little, say, .py file, and then write a small Python program, and then run it at the terminal. Okay? So that's the goal. And then maybe if we have time, also run a Java or C++ or whatever program as well. Okay? So first, let's talk about backups. So I already told you about them, but to actually try them out, in your project, if you click on the Files tab, you'll notice kind of hidden off to the very right, there's some links over here. One of them on the very far right is labeled Backups, and it has a little life preserver, or like a little ring that you can grab onto in case of disaster. Also, there's a trash. There's a button to show hidden files. There's a button to change the sort order to alphabetical order instead of most recent. And there's a button to refresh the current listing. So let's click on Backups. If you click on Backups, the first time you click there, it might take a few seconds to load this listing of backups. You should have your project open. Let me check to see if you guys do have your projects opened. Going over here. Well, okay, that looks somewhat promising. Some people have their projects open. Lots of people do, because that says that they were recently modified. Good. Okay, so if you are in the files, you can click on backups, and you'll get a big list of these directories whose label is the time. And depending on how long you've been using your project or how long it's existed, there's more or less of these snapshots. So for me, it goes back 4 days because I created this project about 4 days ago. I have other projects that I created many months ago, and so then it goes back several months. Okay. And if you then click on, let's say, I'm going to click on this 1 hour ago, what you get is something that looks just like your project and has all the same files, except it's as if it was 1 hour ago. So it's all the files in their state 1 hour ago. Okay? And then you can, click on things like, I don't know if you remember, on Wednesday we made a Scratch folder and put a bunch of files there. If I were to go back a little farther than, I'll go back a couple of days before we did that to 3 days ago, and notice there's no Scratch folder. Okay? The idea here is you're working along and then, I don't know, something really bad happens. Your roommate steals your computer and deletes all your files, that sort of thing. You can still log back into SageMathCloud, and even though they deleted maybe all the files in your project, they didn't delete the snapshots that you get in the backup tab. In fact, there's no way for anyone to delete these except for some evil hacker who takes over the system, or me, or somebody else running SageMathCloud. But the security model doesn't allow for regular users to delete these snapshots. They just get periodically deleted after months and months in order to save space. Okay? So don't put highly sensitive information in SageMathCloud and then try to delete it and think it's just going to be gone quickly. This is more designed for, I designed this very much aimed at what I think you guys need when you're working, which is that you don't lose your work. That's probably a much higher priority to you than that you can easily delete sensitive data. Okay? So you guys are what I had in mind in designing it this way. So, I don't know, you get really drunk, you mess everything up, it doesn't matter, you can revert to before you got drunk. Okay? So I described exactly this sort of thing at some biology research institute in downtown Seattle, and they were really mortified by this because they have sensitive information of users and they want to be able to easily delete it and so on. So for them, this isn't quite the right model. But I think for you as students, really you just don't want stuff to disappear, right? Okay, so that's what the backups are, and again, you can. It's just the only difference between these files and the other files is that these are read-only. You can't edit them, but you could do something like click here. You could click on copy, and then you could say, oh, I'd like to make a copy of this file, and I'd like to put it in this location. Okay, so you can choose from some folder and then copy it over. Okay, so that covers the first topic, which is backups. So I put a little exercise to do, which is just to copy a file from a backup. So maybe you can try doing that right now for about 2 minutes. Just click on your backups folder and then go to any backup from a little while ago and click on it. And then maybe in your Scratch, remember we had the Scratch folder, just click on the checkbox, click copy, and then make a copy of that file into your home directory. It'll take a second, and then if you click on the house, you'll see that file got copied to your home directory. Okay? So just do that right now. And then once you've done that, you can also click on it again and click delete to delete the file. Okay? So do that right now. Click on your backups folder, see the backups. You should see a bunch of backups. Or it's just this thing off to the far right. Right? Just click on backups. Any questions? You don't have we can don't do that. You could if you wanted. You could also just quick cancel this. But yeah, that's dangerous if you want to actually. Any questions?
Did you say something?
Oh.
Did say to delete it after you copy it?
Sure. I mean, assuming that you, like for me, I just made a random file and stuck it in my home directory, so it made sense to delete it. Don't delete it if it's something you want. Oh. Okay, so that's the first thing. Moving on. Let's see. By the way, if you find the whole like file thing where you have to click a box here and then do something up here really annoying, you can complain to Jonathan Lee in the back, because he mostly designed that and implemented it. Okay, next, deleting stuff. So find a file and delete it, and then empty your trash. So, okay, I'm just gonna make a file right in the top. Just hit enter, and now I have a file right there. To delete a file, you just click on the checkbox. You can also delete a bunch of files, and then you click delete. And then you confirm. What it actually does right now, at least, I think it changes. What it does is it moves the file to your trash, and then you can see the trash by clicking on the little trash can, and it shows you all the files or directories that are in your trash. And then once you're there, you can then click empty trash and empty it. Empty it. Come on. Why isn't it emptying? Oh, now it's empty. So just do that. Create a file, delete it, empty your trash. Yes? It might be that you're trying to delete a read-only file in your snapshots directory. That would be the one situation where you would definitely end up with an error. Indeed, that's exactly what happened. So her error message, she went to the .snapshots directory by clicking on backups, and then she tried to delete a file there. The error message is horrendous. I don't know if you try that, but you'll get this massive red horrible error message full of pages of text. You can't delete things out of the snapshots directory, which is good. Yeah. Yeah, so just click on the house, and now you can delete the file. Or you can delete something from your scratch here. So you can't delete the backups, which is a good thing. Yes? Yes, you can definitely do that. Yep, that doesn't move it to the calculator. So if you know the terminal, another way of deleting a file permanently without the trash is, and by permanent I mean it doesn't get deleted from the backups, it's just to use the Unix. You can use the terminal, or you can use this little thing in the upper right, terminal, right here. There's a lot you can do there, but let me make a file. And now that file's right here. If you type RM, which stands for remove, and then the name of the file, which is tedious to type because there's no tab completion here yet, it will remove the file. And that just instantly removes it. There's no trash can involved, etc. Although, it doesn't remove it from the backups. So as long as it's been around for a few minutes, it'll be in the backups. Your hand, yes?
Yeah, so what's the process of like things ultimately getting deleted from the backups over a long period of time? Like,
That's it. Eventually the snapshots get deleted.
so it's just like after a year or so,
Yeah.
Everything gets thrown out.
Yep. Except the backup to Google Cloud Storage via Git, that doesn't get thrown away ever. But it's also not accessible except if I literally go in and try to get at it. Okay. That leads me to the next thing. There's some buttons in the lower left of your project, which for this project you're probably not going to use, but there's a button delete project and a button hide project. What hide does is make it so that you personally won't see the project in your main project listing. That's all it does. Any other collaborator on the project, they'll still see it. It just hides it from you. So if I click hide project here, then when I go to my main project listing, and I don't have hidden selected, then I won't see my Math 480 project. So it's just not, there's an old one from years ago. If I click on hidden though, I will see the project again. Math 480. Let's see, Math 480. And, oh, I have to click on hidden, sorry. And there it is. The reason for the hidden thing is that there are certain people, like me, namely instructors, who have a lot of projects of students that they're collaborators on. So they see a huge listing. So it's nice to be able to have them hidden so you don't see them normally. That's all. There's also a button, delete project, and despite the bright red, it's the safest delete button you'll ever see. It doesn't really do very much. It just instantly says, warning, this project is deleted, and then you won't see it in your main project listing or in the hidden listing, but it's still there. It's just deleted for everybody who's a collaborator on it. Deleted in the sense that it's not listed. But if you click the button again, it comes back. There's actually no way to just permanently delete the project yet. I haven't implemented that yet. Some days, the way I plan to implement it is to have delete and then some confirmation, and then you get a week period during which you can change your mind, and then all the collaborators maybe get emailed just in case they want to undelete it. So kind of Google Compute Engine projects work that way, so it seems like the way to go, but I just haven't implemented all that yet. Okay, so moving on. You can also create a new project at any time if you want. You just go to your projects listing and click Create New Project. Maybe you just want to mess around, do something for another class, do something that has nothing to do with the project for this class. And you just click Create New Project, give it a title and a description. You can change the title and description at any time just by going to settings in the project. Doesn't mess anything up to do so. And you just make it. When you make a project, it will by default pop up running on a cluster of free compute servers that we have. You can pay a little bit to move it to a non-free server that is much faster and much less loaded. But you can make as many of these free projects as you want. There's no charge at all, and each one has 3 gigabytes of disk space, and you can just make an unlimited number. They're all private. Everything in them is private by default, and you can add as many collaborators as you want. The only functional difference between a free project that you might create here and now and the one I made for the course is that it may be running on a much more heavily loaded machine. That's it. And it has, it also doesn't have outside network access by default, whereas the one I made for this course for you does. Yes?
Besides, like, for organization purposes, is there like any interaction among the files in the project, or like, kind of any functional reason besides,
So it's the unit of collaboration also. So a project is, any collaborator in the project has equal kind of ability to do stuff with the files in that project. And so if you're going to do something with a certain group of people, you make one project and then add people as collaborators. If you're going to do something else with a different group of people, make a different project. And then there's also things like the logs. So like here I have all the stuff in my log related to this course. And in another project, I'll have a log that's related to that other thing. So it's really just an organizational unit and also a collaboration unit, or boundary or something. Let's see. I think my project was hidden from you, which is disturbing. Okay, so you can make projects, etc. Okay, so now let's get into some specific stuff. So, actually, just in the context of making projects, one other thing to note is if you click on the Help button, which I still haven't shown you, in the upper right there's a button Help. It has first a little box at the top which says email this if you're having trouble, include a link to your project. So that's a mailing list, help@sagemath.com, that is read mainly by 2 people, me and a guy in Austria, who is able to answer support requests when I'm asleep. And so if you email that link and you have issues, or sorry, if you email that address and you have issues, then we'll hopefully resolve it pretty quickly. There's also some other information here, like frequently asked questions, has a lot of stuff. You can read the source code, SageMathCloud here, etc. And then an interesting thing is system usage. This gives you a sense of how much SageMathCloud is being used at a given moment in time. So right now there's 436 users that are connected. What connected means is they opened up their browser and they looked at they're looking at SageMathCloud, and it hasn't gone into standby mode. After about 15 minutes, if you do nothing at all, it'll go into idle standby mode, and it disconnects at that point. So these are really 436 users who are active in the sense that they've done something in the last 15 minutes. Or they may have changed the idle standby timeout, which you can do in account settings. For example, I made mine 30 minutes. So as long as I do something every 30 minutes, it stays connected. So there's almost 500 users right now, 133. So there's a very high bar for how active that is. But there's 133 that are extremely active. You might wonder where they are. That's kind of fun to look at. So I'll show you the Google Analytics for a second. The real-time Google Analytics. You get a map with little dots where everybody who's edited a file in the last 3 minutes, I think, is located. So it's mostly us in Seattle right now. 52 active users here. Good. And then you can see there's somebody in South Africa and other places in the world. UCLA, East Coast somewhere, New York. Somebody from Facebook. Okay. And then there's some usage like per day. Another useful one is system metrics. So what this does, there are 4 free compute machines and 4 members-only compute machines. All your projects for this class are on the members-only machines, and this gives the load on those machines. So you can see that the free machines are more heavily loaded than the members-only machines. These are also more powerful, like twice as many processors, more RAM, etc. And then also you can see how many copies of the Jupyter Notebook are running, how many projects are running, how many Sage worksheets are running, etc. Okay, and then this has historical information over time, and so on. And it gets updated frequently. Okay, so now back to the next thing. So now what we're going to do is just look at a couple of specific file types. We'll make a Jupyter Notebook, we'll make a task list, and we'll also try to run a program. Okay, so let's get going. So the first thing to do is to make a Jupyter Notebook. Find your Scratch directory. So you can click on the little house to get to the top level. And then you made a Scratch directory last time. If you weren't here on Wednesday and didn't make a Scratch directory, you can click New, and then type Scratch, and then click Directory. And then you'll have a Scratch directory. And it just has like a mess of files in it that we've been playing around with. So just go to that directory. Then you can either click New, just click New, and then you can give this another name if you want, or just leave it like that. And then click Jupyter Notebook. And that will create an interactive Jupyter Notebook. It also starts up a copy of the Jupyter Notebook server, which depending on load can take like 30 seconds. Once it starts running, then it's instantaneous because it's already running. But initially it can be kind of slow. So we'll see how this goes. You may get like a little faint error for a moment, but then it'll retry. Also, if it doesn't work in about 30 seconds, you can close and reopen the file, and it's very likely to then work, which is what I'm going to do because I'm very impatient. And I closed it and reopened it, and now it looks like it's probably going to work. I'm optimistic. Boom, it worked for me. Woohoo. So now once you get it to come up, then you can type something and hit enter, and hopefully it'll start running. This little indicator on the right is the kernel, and it tells you whether it's connected successfully, which apparently it hasn't yet, which is really weird. No connection to kernel. Huh. That's weird. Okay, if it doesn't connect to the kernel, you can click kernel restart and then it will connect. And then it works. Okay, so your goal is just to do one simple calculation in a Jupyter Notebook. And then once you've done that, you can look around at some of the menus, maybe Google Jupyter Notebook, etc., and see what it is. And then one interesting thing is change kernel. You can see some of the other things like Julia and Octave, which is MATLAB-like, and R. You can set the whole Jupyter Notebook to switch to one of those modes, and then you just start putting R code in, MATLAB code, etc. Okay, so I'm going to walk around and make sure you're successfully able to do this. Remember, the only clever trick I did was just close the file and open it again if it didn't work. So good. And these are collaborative, just like everything else. You can have multiple people look at them and edit the same one. And you can try changing the kernel. And you shift enter. So if you type something, you type shift enter to evaluate, or click the play button. Questions? I think you made a markdown cell, so you might want to change it to a. And you get shift enter or click the. So just to give you a little sense of the Jupyter Notebook, it gets used a lot for publishing scientific stuff that's interactive. For example, remember that gravity thing? You guys know what I'm talking about? Sorry for being incredibly vague. Yeah, so they made a big Jupyter Notebook in which you could play around with the Fourier transform type stuff involved with the analysis of that data. It's popular, and that's just an example of where it's used. Notebook validation. Yeah, it could be. It could be because of the long error. And it start working again. Oh, they're going to be no, just let me know if you have any questions. By default, you can type arbitrary Python code. So that's what you can do. So if you know anything in Python, you can try it out. Yes? Oh, it looks like me, sadly, your kernel didn't connect. So if you go over the kernel and then try to reconnect, so you have to click on that kernel menu item. Yeah, and then go to reconnect. Try that. Because it looks kind of broken. It has a little broken icon. Yeah, so you have to click on kernel reconnect. I think you didn't click that. So kernel and then reconnect. Let me try to refresh. Okay, yeah, and then, no, well, this is a little faster. It doesn't have to reload everything. Now try shift enter. Yeah, that's right. Any questions? Sort of work kind of fun. All right, any questions? So, cool. Successfully used Jupyter Notebooks. So there's a lot of different kernels here. I'll just give you a little taste of them. It's a little annoying because when you switch the kernel, it just switches the entire notebook. And so if I do something with one kernel here, and then something with another kernel there, and so on, it doesn't know at all that that kernel was used to evaluate that cell. So it's kind of ridiculous, but that's their design. But in any case, as long as you're using only one kernel, then it makes sense. But in any case, so this is something you might type in MATLAB. And I switch to the Octave kernel. Octave is like a free open source competitor to MATLAB that uses the same notation. So I tried, for example, switching to Octave mode and then going through one of the tutorials on the MATLAB website, and everything worked. All the graphics, all the input just worked fine. So you might be able to do your homework that involves MATLAB, say, using this instead. And there's an R kernel, so you can do R stuff. So I'll compute a standard deviation. Wow, that's not right. And boy, does that error look ridiculous. Okay. And there we are, our validation error. Okay, so that's weird. Maybe there's this, that's strange. Am I doing this wrong? That looks like R code. Oh, I'm doing it wrong. Okay. I was typing, I mean, it was completely wrong, but okay. So there's the standard deviation using R right there. So I typed nonsense, but and I got some horrendous thing out. Okay, there's a Sage kernel, which lets you do things like, use powerful mathematics. So I don't know, integrate sine of x squared with respect to x and get an answer. And I can maybe do plot of sine of x squared also. X going from 0 to 10. And then you get a plot. Okay, so that's Jupyter Notebooks. And let's see, moving on in our tour, let's see, to-do lists and writing a program. Okay, to-do list should take like 2 minutes. I barely mentioned them before, so I'll just show you again. So again, go to your Scratch directory, and then you can make a to-do list. And you just like making another file, you just click task list. It's a file that ends in, the extension is .tasks. And here's what it looks like. Just like a blank page, you can create a new task. And you can do things like finish your homework. And there's a due date that you can select over here, a due date and time. So in this case, it's due at 6 p.m. So I'm just selecting that right there. And you can make lots of different tasks. Obviously everyone here has used to-do lists a lot, but the interesting things about this to-do list are that it uses Markdown for the input. So you can do like title, foo, bar, you make a little list, and it looks like that. But it's Markdown with support for mathematics. So prove that, I don't know, the integral from 0 to alpha of blah. I'm just putting nonsense here. But you can use mathematics in your task. So that. You can use hashtags. So this is hash important and math. And whenever you make a hashtag, what it'll do is it makes a little button associated to the hashtag at the top. And then also this is a button. And what you can do is when you click on the hashtag, it will show only the tasks that have that tag. So it's a really easy way to find only the stuff having some property. Of course, you can also just search, like foo, and it'll show only the tasks that have foo in it. By default, it orders by the column which is custom order, and with that you can just drag tasks around. So I can just take this one and sort of drag it to the top if I want, and it sticks in whatever order you leave it. But you can also have it order by when you last changed the task or what the due date is in either direction. So that seems kind of random when the due date is done, or is not set. That's weird. I feel like I'm looking at a bug because the third one is due before the first two. So that's really not right. You can also click on time travel, just like with the other things. And your to-do list, you can go like this and see kind of how your to-do list evolved over the last few minutes. And if you select change, that's useful because then you'll see whatever the last changed one was, which is usually what you want to do. Okay. You can also do things like, delete stuff. If you click on this box, you'll see the deleted things, and you can undelete them or delete them forever. And there's a little help page which tells you about to-do lists in more detail. One other thing with the Markdown, you can put a little box like that. So if these were a couple of separate tasks, and you'll see that in the Markdown, it turns them into actual little boxes. See at the bottom? They're like little check boxes. And if you check on them, then it will put a little X in there. So the check there corresponds to the X there. And so you can make like a task that has a bunch of subtasks, and you just put little square boxes like that. Also, if you have a file that is related to a task, like this particular file, then you can just paste it in here, and the link will behave in a sensible manner. So when you click on it, what will happen is it just, oh, that's not sensible. Okay, it doesn't behave in a sensible manner at all. I was hoping that it would just open directly that thing, but it doesn't. But in my mind, someday it will. And it does in various other places. So, sorry. In chat rooms, it works properly. So in the chat room, when you put a link in, it does what you expect. This is a link, and then that chat. See, it just directly opens the link, which is, of course, the right thing. But I haven't apparently done that yet for task lists. Okay. Continuing our tour. Oh, I'm going to close. I have a whole bunch of tabs opened at this point. And when you close them, if I want to close a whole bunch, I can just sit here and click, and it doesn't like resize them all the second you click. It doesn't resize them until you move your mouse away, which is very nice because that lets you click and close a whole bunch in a row. See? It only resizes them when I move my mouse away, which may not seem like much to you, but Nicholas Ruland, who's an undergrad here, and I think Jonathan Lee, spent a lot of time making it so that actually works, just because it makes it a lot easier to close a lot of tabs. It's the same thing that Chrome does, by the way. Okay, so finally, the last thing we're going to do is run programs written in other languages. Very, very simple ones. The way you do this, so if you create a new file that ends in, say, .py, you can then put Python code in the file, and then you can load and run that code somewhere else. You can load it into a Jupyter notebook. You can run it in a Sage worksheet. You can also make a command line terminal and run it there. The one thing there isn't currently is a little button right in the file that just directly runs it. But it's pretty flexible because you can create files of almost any type, and as long as there's an open source compiler for that type of code, you can run it. So for example, Haskell, Lisp, Fortran, Julia, all these programming languages, pretty much every open source one that anyone's ever asked for in SageMathCloud, you can open the command line terminal and then compile code and run it for that language. Okay, so let's start with trying to do this for Python. And so what I'll do, and I hope that you'll do it as well, is I'll go to the Scratch directory. I'm going to make a new file, and I'm just going to remove that time and put, I'll call it hello.py. I'm going to write a little Python program. So you should make a file hello.py, okay? So you just type hello.py. Here, I'll zoom in for a second so you can see that really clearly. And then you could just hit the return key or click on the file button right here, and it will create that file for you. It's just going to be a blank file. In a moment. Okay, so we now have a nice blank file, and now it's going to be a very simple Python program. Print hello world. Okay, so we get really generic. And you may want to click on save after you've created the file. Now, if you try hitting Shift-Enter, it's not going to be very exciting. It does nothing. Maybe you'll get a new line. That's it. This is not a Sage worksheet, not a Jupyter notebook. It's just a file. You're just editing it. You could have written this file also in some text editor on your desktop or your laptop and uploaded it by drag and drop. And so there you have it. And now let's run it. And so what we're going to do is, well, I wish it was click a button and it would run here in the output, but I just haven't got around to implementing that. So what we'll do instead is we'll make a terminal, or you can open a terminal that you already have. So I'll just click terminal. And by the way, this workflow of writing some code in a file and then using a terminal to run it is very generic. It's not at all a SageMathCloud thing. Like in 1991, when I was a computer science undergrad, long ago, that's exactly what we did. You opened a text editor, you edited code, you built and ran it somewhere else in a terminal. So it's pretty standard and general. So now we want to run hello.py. So I think you can type Python hello.py, maybe. Yes, it worked. Okay, so the little bit of code in that file, it could have been some really complicated thing that takes 3 days to run and pulls in all kinds of libraries, whatever. But you could do this. Yes?
So it checks from like your current directory, like to the file?
Yeah, yep. You can give a path though, like I think you can do Python scratch hello.py, like that. So, and it's forward slashes in Unix, not backslashes like in Windows. So your goal right now is to make a file with a very simple program in it, namely print something, and then run it. Okay, that's it. And if you do that, you can try, if you happen to know Java, I know, how many people here have programmed in Java a little bit? Like every single person, because it's a prerequisite. So you'll notice that there is a Java compiler installed. And what you can do is make a file that ends in the right ending for Java, and then Hello World is a little more complicated, is amusingly complicated in Java, but you can Google and quickly find a half-page long Hello World. And then you can compile it using the Java compiler, and then run it. You'll get an executable, and you can run it on the command line. Okay, so that's what you should try to do. Run a program written in some language in the next 2 minutes. I have no idea. Does anybody else? No, not me. I've never. Alright. Switching to like this space right there. Oh. So if you focus that and then backspace trying to switch to some sort of mobile app that you come up with. That's unnecessary. The problem with the little sense. So the only problem that you might have is or that the program is I think there you might have there may have to be a relationship between the file name and the class in Java. Okay, so remember to be done with your assignment by 6 o'clock tonight, and then I'll see you on Monday as usual. There's a three.
Not too bad. Are you still playing today?
Plus 2 hours, 7 hours of class. Why?
No. I think it's dinner, but it's like nobody's yeah. Like
Not a chance to
like everything good for you though?
Yep.
Sure. I only do Monday and Friday.
So,
Yeah, this Wednesday, like, just saying,
I dropped 2 points, right? And so, yeah, I guess.
how about AI?
It's worth 10%.
It was like,
Yes. Great. Sure. Sure. You can copy and paste this. You put your cursor on like for the 6s. Yeah. Oh, sorry. Right there. And then you can do shift up arrow and command C. And go back over here and Okay, no. Is this exactly what you want?
No, I want to get rid of this part.
You want to delete this? Yeah. Do you want everything? Well, you should be able to copy and paste
Yeah.
what this is. Copy and paste before. How's that? Now you can delete. I just did more like before I didn't quite copy and paste enough. You can copy and paste any amount. You have to keep going up. So I didn't go up far enough this time. So you can just go to the very top and hold the shift key. Yep. You can do Command A and copy everything. Yeah. Yep. As long as it's saved, that's it. That's all you have to do. Yep.
Is there a way to
I think you have to put a checkbox.
So I can't figure out how to run this from, I've never used
I think
the
it would
terminal.
be that. Oh, okay, that makes it for long. So after you do that, open another file that got created. So you can look at the files where it types ls. So it's my way to fix it.
Yeah.
Sorry, not JVac, also just ls. Okay, so yeah, it makes something up. Now somehow you can run that. Probably Java, hello, Java. No, they sent me like, is your, let me look at your code. Call hello.
I'll show you.
Maybe you don't actually say that. Yep, there it is. Hello. So it just like finds the dot class. It was trying to run like hello dot class instead of hello class.
Right, yeah.
So it kind of
Cool. Thank you.
yep. That's about it. Any questions?
Yeah, so,
Okay, unfortunately, it's not so simple. Unless people see. Too many other people did 4 or 5 times.
Yeah.
Sure. Okay, so you need to do. No, that. Then you have to have the other stuff. You know, like the public classes, void. So what you do is first you do JDAP, then the hello dot, and then you do Java hello, Java space hello. Yeah. But the cool thing is, once you figure out how to do that, and you should be able to find stuff that's not instructions, but you can line into any computer and that's right.
Question.
Sure.